I said last class we did chemical kinetics, that is rate of chemical reaction. And then we said the rate of chemical reaction talks about the speed of the chemical reaction. That is how fast or how slow the chemical reaction is. And we said based on that, we have very slow reaction, very fast reactions, and moderate reactions. So we said very fast reaction, they are very instantaneous, they occur within seconds, while moderate reactions may take minutes or hours to occur, while very slow reaction may take up to a year or years before they can occur. I'll give an example. Then we listed some factors that affect the rate of chemical reaction. So let me select 7 people now. So each person will tell us each of the factors, and now they can affect the rate of the chemical reaction. Are you ready? So I'm selecting 7 people now.
Yes, sir.
So you tell us the factors that affect the rate of the chemical reaction and how they affect the rates. Augustine, Elijah, are you there? Augustine, Elijah, are you there? Okay, if you know you want to, you know the answer, just raise your hand. I will just pick randomly. You know you can answer, raise your hand. Let's see. Israelology, I'm not calling you. Others can raise their hand. Okay, Blessing. So can you give us temperature? How does temperature reaction?
Increase in temperature in a reaction increases rate of reaction, thereby stimulating the catalyst.
You are missing them up. When you increase temperature, what happens to the particles?
If you collide with your
we collide more as a result of what? Like, so one word, I mean, you like the one word now too.
Increase the kinetic energy.
When you increase, that's what I want to hear. That's it. When the temperature is increased, the particles they gain more kinetic energy, and that's why they collide more, because they now move faster. So their collision will increase. Thank you. That's Blessing, right? Can you give us one?
So let me answer one. If they answer my own, you go pay me.
You have 7 now. I can't read it, but so can you tell us?
Yes, sir. Increase in pressure.
Okay, how does increase in pressure? How does it affect the rate of
it increases their collision, especially in gases.
Increase. Let me repeat it. It increases the frequency of collision. Okay, the pressure increases the frequency of collision. Yeah, thank you. Let me say this. For gases, we talk about pressure, right? But they can also talk about volume. From Boyle's law, we know that volume is inversely proportional to pressure. So if increase in pressure, we increase the frequency of collision, increasing the rate of reaction. A decrease in volume will increase the frequency of collision for gases now, because when you increase the pressure of gases, the volume will decrease, and when you decrease the volume, the pressure will increase. So increasing the pressure of gases or decreasing the volume of gases, you are increasing pressure.
What you said. You said if you decrease the volume, what happens?
And when you increase pressure,
following the law of Boyle's law,
increasing pressure is the same thing as decreasing volume for gases based on Boyle's law. Remember, volume is inversely proportional to pressure. So when you increase the pressure, the volume decreases, so the rate of reaction will increase. Do we get that? Now let's take some questions on that before we move to our next topic. Just pick some questions randomly here. Okay, we have question number 1. Can we see that? Can we see question 1?
No, sir.
Yes, sir.
I'm not seeing anything.
Yes, sir.
Maybe it's the network. Can we see question now? The question says,
Okay, I can see it, sir.
which of the consider the reaction H2 plus I2 equals to giving us 2HI. Which of the following will decrease the number of effective positions of molecules of the reactor? So they're asking for the one that will decrease the number of positions. So indirectly, the one that will decrease the rate of reaction. So number one, A, if we increase the pressure, what will happen to the rate of reaction?
It will increase.
It will increase.
So that means A will not be the answer, right? Number two, rise in temperature. When the temperature increases, what happens to the rate of the reaction?
It will
It
increase.
increases.
Yes, sir.
It will increase too, right? So which means B is true. When you increase the volume of the reaction vessel, when you increase volume, increasing volume means you are doing what to the pressure. It means you are decreasing the pressure. So if you decrease pressure, what will happen to the rate of reaction?
To increase.
When you increasing volume is decreasing pressure. So when you decrease pressure, it will decrease the rate of the reaction. So which means that is our answer, right? Remember, when you introduce a catalyst, it's going to increase the rate of reaction. So what's our answer now?
Option C.
That is
See,
right.
that's increasing the volume.
Okay, good, thank you. Number two says, which of the following factors will slow down? That means that will decrease the rate of the reaction. Number one, exposure of the reaction vessel to sunlight. Number two, addition of distilled water to the reaction vessel. 3, increasing temperature. D, presence of MnO2. So the first one says exposure of the reaction vessel to sunlight. This is the composition of hydrogen peroxide. The composition of hydrogen peroxide is also a photochemical reaction. I gave us some examples of photochemical reaction the other time. We said conversion of silver halide to silver metal in photographic film. We talk about photosynthesis. We talk about reaction between hydrogen and fluorine in light and needs presence of light. Also, I told us that we have a lot. So one of them is also the composition of hydrogen peroxide. So the composition of hydrogen peroxide is a photochemical reaction. So when you expose it to sunlight, the rate of the reaction will increase. So that will not, we are looking for the one that will slow down the reaction. That is the one that will decrease the rate of the reaction. So A is light. In the presence of light, the reaction will be faster. It's a photochemical reaction. B says addition of distilled water.
Yes, sir.
When you have distilled water, that means you are decreasing the concentration. You are decreasing the concentration. So that means you are diluting it. I think I will do some questions on that. When you dilute a solution, it will reduce the concentration of the reactant particles. So the reaction will be slower. So when you decrease concentration, reaction is slower. When you increase concentration, reaction is faster. So because you are distilling the solution, the reaction will be slower. So that is the decrease in the concentration. Then C, increasing temperature. Remember, when you increase temperature, the rate of the reaction will increase. So C, increasing temperature will increase the rate of the reaction. Then D, presence of manganese oxide. Manganese oxide is a catalyst. Catalyst will increase the rate of the reaction. So the only one that will decrease the rate of the reaction then, according to the question, would be addition of distilled water, which will dilute the solution. So diluting the solution will decrease the concentration of the reactant particles, so the reaction will be slower. So dilution will decrease the rate of the reaction. So our answer there will be what now?
B.
B.
B, sir.
Do you get
B.
that?
B.
Now,
Yes, sir.
3 now says, page 3. In the chemical reaction above, the substance that will increase the rate of chemical reaction. This is Haber process. In the Haber process, the catalyst used is finely divided iron. Finely divided iron is the catalyst in the Haber process. So we use finely divided iron as catalyst in Haber process. Platinum is used as catalyst in hydrogenation of oil, production of migraine. You can use platinum or palladium. Vanadium 5 oxide, that is V2O5, is the catalyst in contact process. That is production of H2SO4. Finely divided catalyst can be used as catalyst in some organic reactions, maybe like dehydrogenation. So we'll talk about all this later, because we still look into catalysts under chemical equilibrium. So we still look into catalysts. So in the Haber process, production of ammonia, the catalyst used is finely divided iron. That's the catalyst used in the production of ammonia. I believe you get that. So all the four substances they are catalysts. The one that is used in the Haber process is iron. Do you get that? Number 6. Number 6 says the activation energy of a reaction can be reduced by what? The last class we talked about activation energy too. I would say activation energy refers to the minimum energy required for a chemical reaction will occur. So if a chemical reaction will occur, the minimum energy required by the reacting party